Hello everyone, my name is Ian Gorton and I'm the author of Foundations of Scalable Systems. This video complements the materials in Chapter 1 of the book. In this module, I'm going to explore the relationship between scalability and cost. Let's take a trivial hypothetical example to examine this relationship. Assume we have a web-based system that can service a load of 100 concurrent requests with a mean response time of 1 second. We then get a business requirement to scale up this system to handle 1,000 concurrent requests with the same response time. Without making any changes, a simple load test of this system reveals the performance shown here on the slide. As the request load increases, we see the mean response time steadily grows to 10 seconds with the projected load. Clearly, this doesn't satisfy our requirements. The system simply doesn't scale. Clearly then, some engineering effort is required in order to achieve the required performance. The figure here on the slide shows the system's performance after this effort has been expended. It now provides the required response time with 1,000 concurrent requests. Hence, we've successfully scaled the system. Party time! A major question looms, however, namely how much effort and resources were required to achieve this performance. Perhaps it was simply a case of running the web server on more powerful hardware. Performing such reprovisioning on a cloud might take 30 minutes at most. Slightly more complex would be reconfiguring the system to run multiple instances of the web server to increase capacity. Again, this should be a simple, low-cost configuration change for the application, with no code changes required. These both would be excellent outcomes. However, scaling a system isn't always so easy. The reasons for this are many and varied, but here's some possibilities. Perhaps the web server code needs redesigning to reduce the processing time per request. Or the database needs redesigning to eliminate hotkeys that become query bottlenecks. This will require a schema redesign as well as code changes to the application data access layer. In the worst case, the web server framework that you selected might have emphasized ease of development over scalability. We can't easily scale it, and therefore a complete rewrite is required, using another framework or, in the worst case, another programming language. Now, let's assume at the low end that optimizing the server code takes about 100 hours of effort, and rewriting the code for a new framework or language takes 10,000 hours. In both cases, we've scaled our system, but one has cost 2 orders of magnitude more and no doubt taken a lot longer. Even worse, while the development is underway, the application may be losing market share and hence money due to its inability to satisfy growing customer request loads. These kinds of situations can cause businesses and systems to fail. We'd never expect someone would attempt to scale up the capacity of a suburban home to become a 50-story office building. The home simply doesn't have the architecture, materials and foundations for this to be even a remote possibility without being completely demolished and rebuilt. Similarly, we shouldn't expect software systems that do not employ scalable architectures, mechanisms and technologies to be quickly evolved to meet greater capacity needs. The foundations of scale need to be built in from the very beginning with the recognition that the components will evolve over time. By employing design and development principles that promote scalability, we can more quickly and cheaply scale up systems to meet rapidly growing demands. So our overall goal when scaling a system is to achieve the required capacity at the lowest cost. Software systems that can be scaled exponentially while costs grow linearly are known as hyperscale systems. Hopefully now the link between runtime performance and scalability and costs is clear to you. Thanks for watching.